Continuing our conversation on data collection and sampling techniques, we use data to help us make more informed decisions, and we have to collect data in an appropriate way. If we don't collect data in an appropriate way, the data is useless. It does not help us make conclusions. Higher level statistics classes and other classes that use statistics pretty extensively, like psychology, will go into more detail on the experimental design and survey creation techniques in statistics. We tend not to focus on the survey creation. We'll look at some bad questions, but on our level, we don't cover in detail the experimental design and the creation of surveys. The sampling techniques we talked about in the previous lesson fall into two categories: probability sampling and non-probability sampling. Now, we just came from the chapter on probability. Probability sampling uses randomization to ensure that every element of the population gets a chance of being part of the selected sample. So every element of the population has a chance of being selected. When we perform random sampling, we can make valid conclusions. Probability sampling is a good thing. Non-probability sampling does not rely on randomization. The technique is more reliant on the researcher's ability to select elements for a sample, and the outcome of the sampling might be biased, and it makes it difficult for all the elements of the population to be part of the sample equally. We also call this non-random sampling, and the biggest difference is this idea of randomization. If we have randomization, every element gets a chance to be part of the sample. And we want this if we are trying to make conclusions for a population. Let's take some examples. On the 12th anniversary of the death of Elvis, the King of Rock, a Dallas record company sponsored a national call-in survey. Listeners of over 1,000 radio stations were asked to call a 1-900 number at a charge of $2.50 to voice an opinion concerning whether or not Elvis was really dead. It turned out that 56% of the callers felt that Elvis was alive. What is the population that we're interested in? Who are the people that we are studying in this situation? Because we're talking about listeners of radio stations. This is our population. So all the listeners of the 1,000 radio stations is our population of interest. What's the sample? What are we actually collecting the data from? The listeners who called in. What kind of sampling was used? As far as the sampling goes, the listeners were asked to call a number to voice an opinion. Since they were asked to participate, this is a voluntary response sample. Kind of like American Idol. They're calling in with their opinion. Do you think this 56% is an accurate reflection of beliefs of all Americans on whether or not Elvis is alive? Probably not. Only the people with a really strong opinion about this are going to call in and pay $2.50 just to hear their opinion heard. I would imagine this is a very small sample. So this is likely not a good reflection of the entire population of all Americans. LPC wants to know the most effective way to contact students. Email, snail mail, or telephone. Snail mail is that stuff the post office delivers you, in case you didn't know. An alphabetical list of all current LPC students is created. A survey is sent to every 20th student on the list. 75% of the students prefer email, and it gives you a little bit of extra information. The survey response rate was 5%. The population of LPC students is about 10,000. So what is the population of interest? Who are we interested in? Current LPC students. What is the sample? The sample is the students who responded to the survey. What kind of sampling was used? If we start at the beginning of a list and we go down to every 20th student on the list and send them a survey, we're not splitting into groups, so we don't have stratified or cluster. And a simple random sample wouldn't be so systematic. Every 20th person, this is a systematic sample. And do we trust the result? Is email a good way to contact students? Maybe, but let's take a look at the numbers. So if we have 10,000 students and we send a survey to every 20th student, we're going to divide this by 20 to figure out how many surveys were sent out. So 10,000 divided by 20 is going to give me 5,000. 5,000 surveys were sent out. I'm sorry, not 5,000, 500. Went too far. 500 surveys were sent out. If we have a 5% response rate, 5% of 500, we can use our calculator, we get 25. Only 25 students responded in this survey. This is seemingly small. In Chapter 7, we'll get some formulas that will help us determine the smallest sample size that we need to answer the question to a certain degree of accuracy. So there will be techniques later on in our class where we get to come up with what sample size we actually need. And if we get more than that sample size, that's okay. 25 students is a pretty small sample, especially when we're talking about 10,000 students overall. So there's a possibility that we wouldn't trust it, but this would be a question for you to answer and support. Do you trust that result? Why or why not? I would say I maybe wouldn't trust it. So my answer would be maybe not because of the small sample. It might also depend on how they sent the survey out. It doesn't say in our problem how the survey was sent out, whether it was sent out by email, snail mail, or called on the phone, because that could also be important to know how the survey was sent out. In our next section, we'll be comparing observational studies to experiments and looking at common misuses of statistics.